All right, this is a Unit 1 review. So I've taken a couple of problems from each of the sections and hopefully going over those that will help you as you prepare for the test. So the first one is, what is the rate of increase for the function? Now remember, our function is f of x equals a times b to the x. Here is our initial value. That's just where we start. So if it's initial, that's just a starting point. Our rate of increase is actually going to be our base. So the base is the rate of increase. Now you notice, if I'm looking at this base right here, well, none of those match with my answers. So I'm going to take, and I need to simplify. So the cube root of 24 to the 2x. So first thing I'm going to do is I'm going to simplify 24, and I know that is 8 times 4, or 2 times 12, I guess I could do it that way. 2 times 6, 2 times 3. So that gives me the cube root of 2 times 2 times 2 times 3, all to the 2x. Well, if it's a cube root, if I have 3 underneath the radical, I could take them out, so I can simplify this part as 2 times the cube root of 3, all to the 2x. I'm still not completely done because I still have this 2 power out here. Now, remember, our base is only to the x power. So I've got to take this 2, and I'm going to distribute it between each of these terms. So this is 2 squared times the cube root of 3 squared, all to the x. Now, this will be 4 times the cube root of cube root of 3 times the cube root of 3 is the cube root of 9. 3 times 3 is 9, all to the x. So what is our base? Our base is this section right here. So that would be our rate of increase. That's how it's going up. The next problem is fairly simple. It's just a review of a power to a power. When we do a power to a power, we multiply. So that's j to the negative 12 times the negative 5. The only thing we need to worry about here are signs, negative signs. A negative times a negative is positive, so that would be j to the positive 60. So t, in this case, would be equal to 60. This problem is talking about buying carpet. If we have a square room and she bought 120 feet of carpet, and I want to know what one side is. Well, a square is L times L, which is L squared equals 120. So to solve this, we're just going to take the square root of 120, which we can simplify as 12 times 10. This is 4 times 3, 2 times 5, 2 times 2. And every pair, so if I have 2 times 2 times 2, so 1, 2, 3 2s, and then I have a 3 and a 5. So for every pair, I only have a pair of 2s, so that's going to be 2. And then everything else underneath the radical, 2, 3, 5, I can multiply to equal 30. So it's going to be 2 times the square root of 30 feet. All right. Jane evaluated an expression, 1 over 729. Well, we know that if it's in a fraction form like this, that means there is some number to a negative exponent. So this would be equal 1 over a to the b. So here we have a negative to a positive exponent, so we can tell right away that's not going to be it. Here we have 9 to the negative 3. Well, we have to figure out what 9 to the third is. Well, 9 to the third is 179, so this is 1 over 9 to the third, which is equal to 1 over 729. So that checks out. What about 3 to the negative 6? Well, we can rewrite that as 1 over 3 to the 6th. Again, 3 to the 6th, if we work that out, is 729. So that could also be an answer. If we have 1/9 to the negative 6, that's 1/9 to the negative 6 is the same thing as saying 1 over 1/9 to the 6th. When we have 1 over 1/9, that's actually, we multiply by the reciprocal and we actually get 9 to the 6th. So that's not going to be an answer. Which statements are true regarding the expression below? Check all that apply. So we've got 8 to the negative 1 times 8 to the negative 3 times 8. Well, in the factor 8 with no exponent, is that 8 to the 0? No, that is not true. The factor would be 8 to the first power. So the sum of the exponents, we add up the exponents, negative 1 plus negative 3 plus 1 is equal to a negative 3. So that would be true. The value of the expression is what happens when we actually multiply this out. So if this is the sum of the exponents, so that's our final answer is 8 to the negative 3. Well, if we have a negative in the exponent, it goes in the denominator, so that's 1 over the 8 to the third. So we're not going to have that, but if we evaluate that, we do find that it is equal to 1 over 512. Now we look at these two and we're like, well, those don't look anything similar, but all we're going to do is we're going to say, well, if we add the exponents, are we going to get the same answer? 7 plus a negative 10 is a negative 3, which is what we have up here, so that is correct, and negative 2 plus a negative 2 is not. If you're simplifying an expression, if this whole thing is in parentheses, remember we've got 5 times 2 is 10, but this squared has to apply to the 6 as well. So we rewrite this 6 squared times h to the 5th squared. And 6 squared is equal to 36 times h to the 10th. So 36 would be the correct answer for this problem right here. Combine these radicals. Now if we notice we have 8 times the square root of 5 and 2 times the square root of 45. We cannot just add 8 plus 2 because those are different radicals. But we can simplify this 2 times the square root of 45. If we take 45, that's 9 times 5, 3 times 3. So this is 2 times the square root of 3 times 3 times 5. Well, if we have a pair, they can come out. Now because it's being multiplied, we still have to multiply. So 8 times the square root of 5 plus 2 times 3, and we're left with the 5 underneath. 8 times the square root of 5 plus 6 times the square root of 5, and now we do have like radicals. That is the same thing as 8 plus 6 times the square root of 5, which is 14 times the square root of 5. What if we have a fraction taken to an exponent, taken to another exponent? This looks a little complicated, but because of our power to the power rule, we know 0 times negative 3 is equal to 0. So that would give us 2/3 to the 0 power, and anything to the 0 power is just 1. This one has seemed to trip some people up. What is the simplified base? Now remember, in a function, we have an initial value and a base to an exponent. So we want to find out, when there's only an x as the exponent, what is the base value going to be? So if we look at these, the 2, 2, 4, and 4 are initial values. We can just ignore those. We don't need to worry about those because they are the initial value. They're not being taken to the exponents up here, these exponents. So we're going to evaluate these now and find out which one this will be. So the cube root of 16, so we've got 16 and 64. So the first thing I'm going to do is I'm going to factor 16 is 4 times 4, which is 2 times 2, and 2 times 2. And then I'm going to have 64 is 8 times 8, which is 4 times 2, 4 times 2, 2. And if we notice on 64, we have 2 pairs of 3s. So the cube root, because these are all cube roots, the cube root of 64 is just going to be 2 times 2, which is equal to 4. So if we have the cube root of a number down here, the 64s we know aren't going to work because there's not going to be a radical left underneath. So I can eliminate those two very first. So now I'm left with these 16s. So I have, in this case, I will have the cube root 2 times the cube root of 16, all to the x. Well, this does not match this base. So let's try cube root of 16 to the 2x. Here's where we need to go. The cube root of 16 to the 2x is the same thing as 2 times the cube root of 2 to the 2x. And remember, this 2 we're going to distribute to both of them and leave our x. So 2 squared times the cube root of 2 squared all to the x, which is 4 times the cube root of 4 all to the x. So here is our base. That matches our base. So this one would be our correct answer. Which one's going on? Okay, what is the graph of the function f of x equals negative square root of x? So remember, f of x equals the square root of x, that positive function. If we made a table for x and y values, if we substituted in 0 for x, y would be 0. 1 for x, y would be 1. 4 for x, y would be 2, because those are the square roots. So if we're going to take the negative of this, we're going to make a table as well, and we've got x and y. So 0, the square root of 0 is 0, and a negative 0 is still 0. If we take the square root of 1, square root of 1 is 1, but we've got a negative in front of it now, and so that is a negative 1. I'm going to write negative square root of x up here. If we take the square root of 4, square root of 4 is 2, and then a negative 2 would be the output. So let's look at which one of these graphs mirrors this table. We have 0, 0. We're going to go over 1 and down 1. So we know it's not this one, not this one, and not this one. This is the only one that is 0, 0 and goes over 1, down 1, over 4, down 2. So this would be our correct answer right here. All right, if we're going to distribute, and we've got radicals outside and inside, the distributive property still works. We take 3 times the square root of 3 times 5 plus 3 times the square root of 3 times the square root of 5. Now we know that if they're outside, you multiply on the outside. So this number is not a radical, so we multiply by the whole number outside. So 3 times 5 is 15 times the square root of 3. In this case, we've got radicals, 2 radicals, and a 3. So that's 3 times the square root of 3 times the square root of 5, which can be rewritten as 3 times the square root of 3 times 5, all underneath 1 radical. So this would be 15 times the radical square root of 3 plus 3 times the square root of 15. Because these are not like bases, and because 3 and 15 can't be simplified any further, that would be your final answer. Finally, one thing to be very careful of when we're taking square roots of a squared, if you just look at this, you've got to rewrite it out, a squared b. Well, when we look at it this way, we can very clearly see that that's a times b. And we have a pair, so that comes out as a times the square root of b. If we had ab squared, then that's the square root of ab times ab, because ab squared is ab times ab, and that would just be ab. So if it doesn't have parentheses, you only take the square root of the one that does. So this would be your correct answer. Hopefully that helps you as you prepare for your test. If you have any other questions or concerns about this unit, please reach out and I'd be happy to help you.